Energetic. Heat definitions. Enthalpy change is amount of heat energy taken in or given out when a system is changed, but make sure the pressure stays constant. Exothermic. Exothermic is when energy transferred from system outwards to the environment. So, products have less energy than reactants. Enthalpy change is negative for exothermic reactions. Exothermic reaction examples are combustion of fuel and oxidation of carbohydrates, like glucose in respiration. Endothermic. Endothermic means energy transferred from surroundings to the system. Examples include thermal decomposition of calcium carbonate. Products have more energy than reactants. Enthalpy change is positive. Standard enthalpy's change of formation. This is enthalpy change when 1 mole of the compound is formed from its elements under standard conditions, which are 298 K and 100 kilopascals, and all reactants and products are in their standard state. Enthalpy of formation of elements is 0. Standard enthalpy's change of combustion. Enthalpy change that happens when 1 mole of the substances is combusted completely in oxygen under standard conditions, which is 298 K and 100 kilopascals, and all reactants and products need to be in their standard state. Incomplete combustion forms carbon, which is soot, carbon monoxide, and water. This is less exothermic than normal combustion. Standard conditions can also include 1 moles per decimeters cube concentration of solution and all substances in standard state. Measuring enthalpy change for S reaction experimentally. Calorimetry equation. Energy change in joules is mass of solution in grams multiplied by heat capacity, which is 4.18 multiplied by change in temperature. The moles are converted by dividing by 1,000 and then dividing by moles of limited reactants. Calorimetry experiment in practical section. Assumptions made is that the solutions have the same density as water, which is 1 gram per centimeters cubed, and heat capacity is same as water. Temperature increases mean it's exothermic, so negative sign needed, and if temperature decreases, it's endothermic, so positive sign needed. For mass in equation, it's the solution, but if both are solution, then add both masses together. Measure enthalpy of combustion using calorimetry. This is when fuel is burnt and heats up water in a cup. For mass in calculation, use mass of water, not the alcohol. Temperature increases, so it's exothermic, meaning it needs a negative sign in front of the value. Moles of alcohol used. Errors in method. 1. Energy loss from calorimeter. 2. Incomplete combustion of full. 3. Incomplete transfer of energy. 4. Evaporation of fuel after weighing. 5. Heat capacity of calorimeter not included. 6. Measurements not done under standard conditions, as waters is a gas and not a liquid. Hess's law. Hess's law is the total enthalpy change for a reaction which is independent of the route the chemical change takes place. Direction of arrows can show different routes of reaction. Hess's law normally used when you're working out enthalpy changes that can't be measured experimentally, so you do other reactions that are measured experimentally. Example of when Hess's law is used is when turning hydrated salts to anhydrous salts, and this can't be done experimentally because you can't add exact amount of water and it's not easy to measure temperature change of a solid. So, both salts are dissolved in excess water and temperature change is measured for these reactions. Enthalpy change of formation and combustion calculations. Enthalpy of formation equals products minus reactants. Enthalpy of combustion equals reactants minus products. Use data to form equation, not what the question says. So, if the question says find the enthalpy of formation, but you're given combustion data, then use combustion equation. Mean bond energies. Mean bond energy is enthalpy needed to break covalent bond into gaseous atoms averaged over different molecules. And oxygen doesn't have one because it's the only molecule that contains oxygen double bonded to another oxygen. There is positive because energy is needed to break a bond. Use mean bond enthalpy because that same bond in a compound has different bond energies. An example is CH4, which needs a different amount of energy to break each of the CH bonds. So instead, we work out the average of the energies to find one CH bond for all hydrocarbons. Exothermic has higher bond enthalpy value of products than reactants. Bond energies are reactants, which have their bonds broken, minus products, which have their bonds made. Enthalpy change calculated using mean bond energies is less accurate than combustion or formation because mean bond energies are not exact. Enthalpy of combustion in homologous series. Rise in size of enthalpies of combustion needed because number of carbon atoms increase. Increases by certain amount because up homologous series certain bonds are broken and made. Using experimental results from calorimeter means experimental results are lower than calculated ones because there is heat loss and incomplete combustion, so less energy released. If you can use combustion or formation data, because mean bond enthalpies aren't that accurate as their mean values averaged of bond enthalpies from different compounds.